this video, we will discuss the questions of triangle problem. Okay. So we will solve using the Coulomb's law here. So what it is said here, it is said here, three charges are located at the three corners of an equilateral triangle. Okay, of side 10 centimeter. So it is given this side series of 10 centimeter. Since it is an equilateral triangle, so all the sides are equal. If this is 10, this side is also 10 centimeter, this is also 10 centimeter. And the angle are 60 degree, right? So this is very clear. Now you asked to calculate the electric force on the charge 3 microcoulomb. I'm considering this vertex to be A, this to be B, and this to be C. So for microcoulomb, we know 1 microcoulomb is equal to 10 to the power minus 6 coulomb. This already we have seen. Okay. So directly first we will write what? First we will see the magnitude and then we will go to the direction. Okay. So here if you see, in this case, first we will see the magnitude. So it is what? F1 is the force. Now you see, let's see the force, how we can take the force. All the charges are positive. So obviously this 2 microcoulomb charge will send this 3 microcoulomb charge away. That means it will repel. So F1 force is in this direction, which is due to charge 2 microcoulomb. Similarly, this is also positive charge. Both the charges are positive. So this will also repel this particular charge. So F2 is due to the charge 4 microcoulomb. So you will get the net force from the resultant of the two forces. Okay. So this is the resultant. I think you remember your vectors. And this angle is your 60 degree. So the resultant force F net. Okay. It is equals to what? Square of F1 square of F2 plus 2 F1 F2 cos theta. This is what it is. Okay. This is the entire thing you need to calculate. And here this F1 and F2, these are the magnitude of the forces. So first we will calculate the magnitude. Theta will be 60 degree here because it's a equilateral triangle. So directly what we will do here is we'll write K Q1. We know the formula is what? K Q1 Q2 by R square, right? Here R is your 10 centimeter, which you need to convert into SI unit, that is meter. So it is 10 by 100 meter. Because you know 100 centimeter is equals to what? 1 meter. So 10 centimeter is equals to what? 1 by 100 into with 10. So it is 1 by 10 meter. Clear? So when you will put the formula here, okay, you know it's 9 into 10 to the power 9, right? For 3 microcoulomb, it is 3 into 10 to the power minus 6. And for 7, it is 7 into 10 to the power minus 6. All right? Divided by, it is 1 by 10 meter, right? So it is 1 by 10 whole square. So from here, what you will write? 7, 9, it's 9, then it's 3, and then it's 2. Sorry, it's not 7, it's 2. Okay. So 3 to the 6, 6 9s are 54. Clear? Into 10 to the power 9, okay, minus 12, and this will go in the denominator. You will have plus 4. Okay. 10 square is 100. So it is what? Sorry, it's 2. Okay. So from here, what you will get is, what you will get? This is in the numerator. So it is 10 square. So it is 100. So it is 10 to the power 2. All right. This is giving 10 to the power minus 12. So it is 10 to the power 11. Right. So F1 is equals to what? From this entire, you will have 54 into 10 to the power minus 1. Right? Newton. So this is the magnitude of F1. Similarly, for F2, it is 9 into 10 to the power 9. This is 3 into 10 to the power minus 6 into, here you're having 4 into 10 to the power minus 6. All right. Again, you will write here 10 to the power 2. Clear? And you will calculate it to be equals to what? When you will do the entire calculation, for the power raised to 10, you know, it's 4 3 is the 12. 12 9 it is 108. And again, you will have here 10 to the power minus 1 Newton. Same things were there. And F net force was equals to what? It was 54 into 10 to the minus 1 whole square. That is F1 square plus 108 into 10 to the power minus 1 whole square. It is F2. 2 F1. There is 54 into 10 to the power minus 1. And here 108 into 10 to the power minus 1. F1, F2. And you're having what? Cos theta. You know what is cos theta? It is cos 60 degree. Cos 60 degree is 1 by 2. Okay. This 2 will cancel this 2. And from here, if you see, you can take common what? What are the things that you can take common? 54, 10 to the power minus 1. Okay, you can take 54 into 10 to the power minus 1 whole square. You can take common. Okay, from this you will have here 1. Here if you take out 54, it will be how much times? I think it's 4 times, right? I think it's 4 times. You can calculate it and see more well. Calculation is completely on you, how you need to calculate. Okay, the one which you find more easy, in that way you can calculate. So I think 54 fours, I can just see 54 fours is this. Okay, you can just calculate it and see. Okay, because if you see here, you've taken out the square, right? So it is 54. If you do 108 and divided by, and you will get it to be 4 here. You can calculate because it will be 2 and 2, that is 4 will be left out here because square is there outside. Clear? And inside also you will have some things, some terms will be there. You can see here also I've taken out this 54, and here again we have taken out 54. Okay, when you will do 108 by 54, when you will calculate it and see, in that particular case, this part of solving and simplification, that you can use the calculator, but I don't think that in the examination hall it's allowed. So I would suggest you to do it on your own. Clear? So now let's come back to the calculation. So you will get here to be 2. Okay, just one single. That become 2 square. Here it will be only 2. So if you see here, this is the square term which will come out. So 54 into 10 to the power minus 1. And this will give you root over 7 Newton. Clear? So you got the answer to be 54 into 10 to the power minus 1, which can be written as 54 by 10 root 7. Or you can write 5.4 root 7 Newton. Okay, this is the net force that is experienced by this charge 3 microcoulomb placed at the vertex B due to the other two positive charges. Clear? So that's all. Next, if you see, if you will have some equilateral triangle, if the magnitude is same. Okay, suppose if you are having a equilateral triangle. Okay, this is an equilateral triangle. This is angle is 60 degree. These sides are L. Okay, these are the three vertices. You already know the F net force. It is equals to what? It is F1 square plus F2 square plus 2 F1 F2 cos theta. Cos theta for you is 60 degree only for equilateral triangle. So it is F1 square plus F2 square plus 2 F1 F2 by 2. Right? This 2 and this 2 will get cancelled, and you will have here F1 square plus F2 square plus F1 F2. This is the general thing. This is the magnitude of the forces. But sometimes if you're having the force F1 is equals to F2, magnitude of F1 is equals to magnitude of F2, then you can take it to be equals to F. In that case, you will get the net force is equals to, this is F square, this is also F square, this is also F square, right? Then you will get it to be equals to what? 3F square, right? Which is equals to root 3F. And you know the force F, it will be equals to what? K Q1 Q2 by R square. This is what you will have. So you can just put the value to be here. This is how you can do. You can say this type of problems to be article problems. Okay, if you're having the net force to be equal. But this approach we have done is this approach you can do for any charges given to you. If the magnitude is equal or it's not equal. Okay, so this is how you can solve. That's all in this video. Thank you so much. Have a good day.